I would like to thank you very much for this opportunity to talk to you, and I hope that we'll have an opportunity to have discussion at the end of the talk. Partly because of, as I mentioned, my background. I was born in Morocco to missionary parents, so we were living in a Muslim country. Morocco is essentially Muslim. The Europeans in Morocco were, a great majority of them were French and therefore Roman Catholic. So we were in a Roman Catholic, European or Muslim country. Also, at the time I was living there, and in fact right up until the time I left, there was a great deal of what I think was called at the time terrorism, would now be called freedom fighting, where the Moroccans were trying to obtain their independence from the French, who were the colonial power. Because of that, you tended to stay very much at home and not move around, get out and about a lot. So in a sense, up to the age of 16, which is when I left Morocco to go to school in England, I was very much in a rather cocooned situation where almost everybody that I knew, all the people I mixed with, were Christians, and what is more, very committed Christians, because to be a missionary in a Muslim country is extremely hard work. So you had to be very committed for this. The only sort of non-Christians I would meet would be at school, because I went to the local French school. So in that sense, I grew up I grew up as a Christian. I accepted what my parents told me. I thought about it, but I had no reason not to believe them. When I went to school in Ipswich for 2 years in order to be able to go to a British university, I met for the first time people who would be, well, let's say, anti-Christian, would argue against my Christian faith. And it was a very difficult time. I was a long way from home. I was frozen a lot of the time, having come from a rather warm country. And it was an unpleasant experience. I won't tell you the name of the school because I don't want word to get back that I had a bad time there. Then at the age of 18, I went to university. And there I immediately joined the Christian Union, which was a very strong Christian union at the time. In the university as a whole, there were some 500 members. And in the college in which I was, there were about 20 or 30. And the opportunities there to learn about all the aspects of my faith that had been questioned by the people I'd met at school was a marvelous opportunity. I could talk to everybody. I also met a lot in fellow students who were not Christians. And it was there that I really started developing, if you like, my own personal basis for my faith, rather than just accepting the faith that my parents had taught to me. And that, I think, is a very important thing. I was a pure mathematician. I went up to university thinking I wanted to be a theoretical physicist, but as the years went by, I became more and more interested in the pure side. I ended up doing pure mathematics, and in particular, I did a lot of mathematical logic. I learnt a lot of logic, and my speciality was in algebra, in group theory, if anybody here knows anything about that. I'd read very widely. I've read a lot, partly because of what I mentioned in Morocco. You had to stay at home a lot of the time, and there wasn't television. There was no television, and so I tended to read a lot. I'd read very widely, and I'd read very widely also in not just in my own subject, but in right across all science disciplines. I also enjoyed novels, thrillers. I'm also quite a fan of science fiction, still am. Anybody here like science fiction? All right. 2 out of 3, 2 out of 2 so far. So I'd got a fairly broad knowledge, not very deep, obviously, of quite a wide area. And I developed my interest also in linking what I'd learned about science, what I was doing as a mathematician, and my faith as a Christian. One of the people I met and got to know fairly well at Cambridge was a chemist who used to teach at what was then called the Cambridge College of Arts and Technology, a man named Dr. R.E.D. Clarke. Now, again, I wonder if anybody here has come across him. He wrote quite a lot about his Christian faith and science, but this is going back more than 40 years, going back something like 50, 60 years. He was getting on when I knew him, and that was, as I say, at least 45 years ago. And he also helped to deepen my interest in this. Now, quite a lot of people, like Dr. R.E.D. Clarke, and there are many others who write about science and faith, think about it, are what I might call soft scientists. You see, I claim maths is the one really hard science. In a technical sense, I'll tell you what the technical sense is in a minute. They're physicists, they're chemists, they're biologists, they're psychologists, and so on. There is one fairly well-known mathematician who has written a lot about his faith as a Christian, and that's John Polkinghorne, who, in fact, was one of my lecturers in applied maths when I was an undergraduate, and who was an extremely good maths lecturer. He became a professor at Cambridge at, I think it was about 32 or 33, and then gave it all up and became a clergyman. His books are rather difficult to read. He's a very clever man. Okay, what did I mean by hard science? Well, you see, one of the things about mathematics, which I think, particularly pure mathematics, which distinguishes it from most other sciences, is that it is something that all mathematicians will agree on. Now, if I prove a theorem, or every other pure mathematician in the world will agree that I am right. This is assuming I haven't made a mistake along the way. But if once I've proved it, they will accept it as true. They might think it is trivial or unworthy of being looked at or whatever, but they won't disagree with it. They won't say that's wrong, it should be this. Now, even physicists disagree on whether something is the correct view or not. And they're fairly well settled. Getting biologists to agree, all the biologists in the world to agree on a particular event. Yeah, okay, you're shaking your head. I don't suppose the camera can see that, but yeah. So that's what I mean by hard science. It's something where you know exactly what you're saying and where you can agree whether it's right or wrong. That's not to say that people don't make inadvertent mistakes. There have been one or two very famous cases where people have thought they proved something and later on it was proved false. One that actually made the news not long ago was, I don't know if you remember, about 6 or 7 years ago, there was great excitement. It actually made the front page of national newspapers when Fermat's last theorem was solved by Andrew Wiles. Well, he announced it at a conference in Cambridge. I'm not going to tell you what Fermat's last theorem is. That would take too long. But he announced it, sent it off for publication, and a fault was found in his argument. He'd missed something. That fault was subsequently repaired, and it was indeed, had indeed proved Fermat's last theorem, which made him famous. As one member of here was saying, his son is hoping to solve the next big unknown problem, the Riemann hypothesis, which I also will not tell you about. Anybody wants to know about either of those, ask me afterwards. So, we all agree on the results. Now, let's see if this thing works. Yeah. A mathematical, when I talk about maths, I'm really talking about pure mathematics. It'll start with a set of axioms, that is, certain statements which are held to be true. It uses the laws of logic, which can be set down. They go back an awfully long way. Aristotle, which is what, 2,400 years ago or thereabouts. And applying these laws of logics to deduce results from the axioms, you get your results, your theorems. Now, if I'd been talking to a group 40 years ago, I would have needed only to say Euclid, and you would have known exactly what I meant, because Euclid had his axioms of geometry. And for a long time, Euclid and deductions that Euclid had pioneered, going from the axioms to all the theorems about geometry, was one of the standard subjects of mathematics, indeed, so much so that it distorted the view of mathematics. Fortunately, that's changed, but now nobody knows about Euclid. Now, the thing is, pure mathematics is entirely certain. What does it do to, what advantage does it give to individuals who study it? Well, I think one of the main advantages, and one which makes mathematicians very employable, not just as technically mathematical mathematicians, but in a large number of jobs, is that it teaches you how to think clearly and logically. It teaches you to know what you are assuming and what can be deducted. Mathematicians can make life very unpleasant for people by pulling them up on loose statements that they keep making. A few more mathematicians in the government would probably have stopped Brown from saying British jobs for British people. And that would have helped him. Okay, you are clear about what is assumed, clear about what you can deduce from your assumptions, and you think about it logically. What is also true is that you are very precise in the meaning you assign to words and symbols. One of the reasons, the main reason really, why if you look at a mathematics, advanced mathematics textbook, it seems totally incomprehensible, is that it's developed its own symbolism and language in order to be completely precise. Okay. One example, if you say that a drawing, a line, is continuous, you'd normally say that, define it to say, well, if you put your pencil on the paper and you draw the line, you've got to be able to draw the whole line without ever lifting your pencil from the paper. If I gave you the mathematical description of continuous, I won't, don't worry. If I gave it to you, you wouldn't recognize it. But if you thought carefully about it and unraveled the symbolism used, you'd realize that it's a much more precise thing than this, not lifting the pencil from the paper. Trouble with that is it means that you can only decide about lines that can be written on a bit of paper. Okay. Now, one of the things I want to point out is some of the strange results you can get from mathematics. That is a number that probably everybody knows, pi. Now, I could turn this into a class and try and find out who knows what pi means. Well, it's the ratio of the circumference of a circle to its diameter. I've given, well, the first, I can see it here. The first, 9, I've got 10 significant figures there. It goes on forever. and it's a number which is very, very strange. When people started thinking about numbers, the first numbers you thought of were just counting off 1, 2, 3, however many people are here, etc. Many years, many centuries later, probably, they thought about negative numbers. You started having -1, -2. A lot later, you got rational numbers, numbers that you can write as a ratio of two integers, 2/5, 3. Pi is roughly 22/7, for instance. That's a rational approximation to pi. The Greeks knew about rationals. Then they found that there were irrationals, like the square root of 2, and that caused great unhappiness amongst the Greek mathematicians. Well, you can go further, and you can have algebraic numbers, which are the solutions of equations like the square root of 2. And then you can get numbers which don't fit into any category whatsoever, like pi, and they're called transcendentals. Nothing to do with religion, by the way. And the thing is, there are more transcendentals by a long, long way than there are any other kind of number. So it's just that nobody can find them, or can only find a few. That's another one, which is probably not so well known. Anybody recognize that one? Yeah, you do. That's 3 out of 3. Yeah. Oh, yeah. Exponential growth. It's the exponential growth of your debt if you don't pay off. It's where things grow very, very fast. That is the number, 2.718228128. Now, that looks as if it's repeating itself. It doesn't as it goes on. It's another one of those transcendental numbers. And this is another one. You all were told and learnt and acknowledged that square of any number was always positive. The square of little I is not positive, it's -1. I is a square root of -1. That was introduced only in the, about 1400, 1500, somewhere around then. I stands for imaginary. If you're an engineer, any engineers here? Yeah. Well, as far as you're concerned, it should be J. Engineers call it J. Everybody else calls it I. So draw your own conclusions. So this is a number which isn't even transcendental, it's imaginary. Put the 3 together and you get -1. If you raise e, the exponential number, to this imaginary number times pi, you get -1. I've written it in 2 forms there. The bottom one is the one which is usually appears in textbooks and writings. And a very famous mathematician called Euler, who was, he lived during roughly the whole of the 18th century, and he became the court mathematician at the court of Emperor Catherine of Russia, Catherine the Great. The courts then had the sensible idea of having resident mathematicians, and as I mentioned, if George Brown had had a resident mathematician, he wouldn't have been in so much trouble. Now, that thing, he wrote that down, and he said, "Now I know God exists," because it is so remarkable that 3 such numbers, which are in effect very strange numbers, I, strangest of all, should combine in that way. And one of the reasons they combine is that if you replace the pi by theta, theta is to stand for any number, what you get is just a cosine and a sine. The sine gets multiplied by I. If you've ever had to play around with trigonometric identities at school or university, you would have had a lot of trouble. Use this and they all become dead easy. So use these imaginary numbers and they become dead easy. Okay. Now, what else about it? Well, those are some of the things that mathematics have ended up dealing with. Infinite sets. Have any of you ever thought how you could define precisely, as a pure mathematician would, what is an infinite set? If you're a mathematician, you'd have no problem at all. The problem is there are an awful lot of different kinds of infinite sets. There's an arithmetic of infinite sets. This all started with a man named Cantor in the 19th century, and don't go trying to learn too much about it. He went mad. Wave mechanics. Some of you have probably heard of wave mechanics. They came along roughly at the same time as quantum mechanics at the beginning of the last century. Possibly the most famous name in wave mechanics was a French prince, Louis de Broglie. Quantum mechanics. If you want to stay sane, don't touch it. It's even the quantum mechanics people themselves say that it is very counterintuitive and almost impossible to understand, but it works. Okay. So one of the things that quantum mechanics in particular teaches you is that things which at first sight appear to be totally paradoxical are not. They work. Quantum mechanics, for instance, some of you may have heard of Schrödinger's cat. It's both alive and dead at the same time. Now, one of the people who actually has looked at this and looked at its links with faith, with Christianity, is Professor Donald Mackay. And he gave a talk in Cambridge when I was a student, Freedom of Action in a Mechanistic Universe, and it was the 21st Arthur Stanley Eddington Memorial Lecture. Eddington was a mathematical physicist or a theoretical mathematician, and he was the subject of a television play, was it 3 months ago? Yeah, 2 months ago, 3 months ago, Einstein and Eddington, which incidentally is a very interesting play, very good play. He championed Einstein's theory in Britain at a time when Britain was at war. This was the First World War, and got into a lot of trouble over that. And he was one of the people who ran the experiment, one of the experiments that showed that Einstein's theory of relativity was correct, or was more correct than the theories that had gone before. And he wrote a lot of books, some of them rather mystical, but very interesting, and left a lot of money, which endowed a lecture in his name. It was published, and the memorial lectures are always published. They normally sell about 100 copies. It was published, they had a print run, I think, of about 1,500, which was sold out within 2 days. It is a fascinating lecture, but it is quite hard going. It's practically impossible to get. I've got a copy of it. So anybody who really wants to read it, I'll give it. But he showed how even if you assume the universe to be totally mechanistic, totally tied down by the laws of Newton's laws or Einstein's laws or whoever's laws, and predictable, totally predictable, yet you can still talk about the individuals in the world having freedom of action. Now that sounds totally contradictory. It's not, but it's hard work to read that thing. Donald Mackay was a professor of communication at Keele University, human communication. He wrote also a lot about philosophy as well as about his faith as a Christian, and obviously about communication. Right. But I've kept singing the praises of pure mathematics. Are there any limits to it? Yes, there are. At the International Mathematical Congress in 1900, this occurs every 4 years, except during the 2 world wars, and it's a gathering of mathematicians from all over the world. Generally, there'll be 5,000 mathematicians plus at it. And Professor David Hilbert at that time, was professor at Göttingen in Germany, which was one of the, possibly the center for mathematics in the world at that time. This was at the end of the 19th century. He gave a talk upon where he saw mathematics developing in the next century, as beginning of the century. And he listed a number of questions which he felt were very important for the development of mathematics. And he proved to have been remarkably prescient. One of the questions is the Riemann hypothesis, what is now known as the Riemann hypothesis. Two of the questions that he went were the consistency and the completeness of pure mathematics. Now, this is two important ideas, not just for mathematicians, but also from the point of view, I think, of the way in which, as a pure mathematician, I look at my faith as a Christian. I better explain what they are. Consistency means that in any mathematical system which is large enough to contain all the integers, or even all the natural numbers. In other words, you can construct mathematical systems which only contain a small collection of objects, finite, and they're generally perfectly consistent, and you don't need to bother about them because they're not going to tell you much. But if you've got numbers in them, what you want to be able to show is that you will never get a contradiction. You'll never be able to prove a statement and its opposite. You want it to be consistent. You want to know that you are not going to get contradictions. Completeness is a bit different, but a fairly obvious meaning of the word. You want to know that if you make any formal statement in that system of mathematics, you want to be able eventually to prove whether that statement is true or false. If you've got Fermat's last theorem, you want to know, can you eventually show that it's either true or false? Riemann hypothesis, can you show that eventually it's either true or false? And Hilbert thought that these to prove consistency and completeness in pure mathematics, these were two questions which were of vital importance, and that the answer should be, yes, mathematics is consistent, yes, mathematical systems are complete. Those systems that contain the natural numbers. Well, along came a German, Kurt Gödel, who actually ended up at Princeton because of Hitler. But in the early years, in the 1930s, when he proved this, he was still in Germany. Strange man, he ended up mad as well. It's a common failing of mathematicians. So, don't call the white men in the white coats until the end of the talk, please. And he showed, firstly, that you will never be able to show that any mathematical system containing numbers is consistent. And he showed that in any mathematical system, you can construct a statement which can neither be proved nor disproved. It can neither be proved true nor proved false. No mathematical system can be proved consistent. No mathematical system is complete. Being not complete is perhaps sad, but not tragic. Not consistent could be tragic, because if ever somebody finds a statement whose truth and whose falsity are both proved, the whole of mathematical system, and therefore the whole of physics and a lot of other things, will collapse. It's thought that nobody will ever be able to prove that it's not consistent, but Gödel showed that you'll never be able to prove that it is consistent. There are limits to mathematics, and all mathematicians since Gödel have to take a very basic step of faith, and when they start, they have to have the faith that they are not wasting their time messing about with something that is complete rubbish. It'll be complete rubbish if it's not consistent. Okay. some interesting recent developments in mathematics. These are there more for fun. Oh, hang on, where's my second page got to? More for fun than anything. In the 70s and 80s, one of the leading mathematicians, a man named René Thom, Thom, from France, started a theory called catastrophe theory. It's all about how things could suddenly go very wrong, like public transport in Britain. It was a rage for a while and then tended to die down. Fractals, they were developed by a man named Benoit, I'm not sure I'm pronouncing that properly, Mandelbrot in America. And one of the outcomes of fractals, it's a fascinating subject, are beautiful patterns generated by computers. Now, I would love to have shown a few on the screen, but the only pictures I've got of them are in a book which is copyright, so I haven't shown them. What I have got is a book which has got some of the pictures in it, and if you'd like to look at it later, and I'll wave a few in front of you at the end of the talk anyway. And then chaos theory, which we've all heard about. Somebody who used to look somewhat like I used to look, Michael Fish. If you've ever seen Michael Fish on television, he's retired now, like me. You'll realize that we looked alike for a while, and I have been mistaken for him once or twice. He made his name by predicting that there would not be a hurricane in the south of England, and there was. And the basic reason is chaos theory. The butterfly that flaps its wings in China causes a hurricane to make poor old Michael Fish eat humble pie. It's how very tiny changes in some area of a system can cause immense changes within a relatively short while. And it's very difficult, if not impossible, to know which tiny changes are going to cause a big change. Fractals, the fractal pictures in effect are one way in which these can be studied. Okay, now I'd better get down to precisely what this is to do with faith. Well, if you look at a development of a scientific theory, you gather the data. I know there are scientists here, so if you disagree with what I'm saying, please pipe up. You work out a suitable hypothesis from the data that you've gathered. You test it to make sure that that hypothesis does lead to the data. And then you check it further by trying to look for more predictions that the hypothesis will make and try and check against that. Now, one prime example is gravity. Newton sat in the orchard and got hit on the head by an apple and made him think about the laws of gravity. And he wrote down the laws of gravity, inverse square law. Two bodies attract each other in proportion to the product of their masses and divided by the square of the distance between them. And that explained an awful lot. It explained the motion of planets around the sun. It explained the apple dropping on his head. It explained what happens when you throw a stone and so on. It explains a tremendous amount. And it explains it very well. And for instance, all the satellites that have gone up and for instance, the ones that are used in GPS, I've forgotten now what GPS stands for, the navigation satellites, they have to be, you have to know their position exactly in order for the system to work. And you know that because you use Newton's laws. It was thought to be one of the strongest, most reliable, least likely to be challenged theories. Then Einstein came along and challenged it. And Einstein's right and Newton's wrong. And that's one of the things Eddington did. The trouble with Einstein's theory is, yes, it's right and it's more accurate and predicts more things that are going to happen correctly than Newton did, but for most practical purposes, it says the same as Newton, certainly to any accuracy needed. And it's so much easier to use Newton's laws to calculate, say, where the satellite is or whatever. Now, Einstein's general theory is in question because they're trying to link relativity theory with quantum theory, and the sticking point is a theory of gravity in quantum physics. So the problem is going to be quantum gravity, and one of the present attempts to do it is what is called string theory, and I'm not going to say anything about it, mainly because I haven't got a clue myself. But it is, again, extremely complicated. And as I said, quantum theory is in any case rather counterintuitive. So theories can be wrong. Now, science is only going to look at what it can measure. Newton measured the movement of the planets. Even quantum theory measures what happens. One of its famous explanations was of the fact that sometimes light acts like a wave, sometimes it acts like a particle. It's things that can be measured. And it describes theories which describe how things are behaving, how the light is what is going to happen in a given situation if you shine a beam of light or send it through two parallel slits or whatever. But that is all it's ever going to cover. It's only ever going to cover things that you can observe in the universe, or more likely, near at hand. What does faith do? Any faith is explaining to you more than that. It's explaining to you what the whole story is about, what the whole story of the universe, where it's come from, how did it happen, who created it, what is the meaning of us human beings in the universe. In a sort of very simplified, very, very simplified way, the engineer can tell you can take a car apart and tell you how all the little bits work and why the various little bits make the car go round. But he's not going to tell you about the man who invented the car, designed it, and what it's being used for. I know that is a very limited and has lots of holes in it, but it's perhaps a better illustration is a painting. A chemist or a physicist can tell you an awful lot of detail about the paint and how it's put on the canvas and what colors it is and so on. But that is never going to tell you what the picture, one of which has recently been valued at £50 million, why it is £50 million worth of bits of paint stuck on a bit of canvas with a, I suppose, wooden surround. Okay. How does this help us? Well, as a mathematician, in a sense, I'm somewhat removed from the way in which a practical scientist works. I'm not looking at measurements of data. I just, as a pure mathematician, what I'll do, what a lot of pure mathematicians do, think up a set of axioms, any old set of axioms, work out what they imply, and see whether there's any point to it. Of course, if I did choose axioms at random, they would almost certainly lead to nothing of any worth, interest, or sense. It'd be true, but it wouldn't make any sense. So you tend to pick axioms which you know are going to be of some use. I mentioned group theory as one of my earliest proof, and the same thing was that studied by John Lennox, was about groups. The idea of groups came from looking at the way in which patterns can be symmetrical, and what do the symmetries look like, and how can you change them? You look at symmetries, and you write down, you try and abstract the idea of the way symmetries combine from the saying these are actually symmetries of an object. So one of the things you look at is if you apply two symmetries, two alterations to a picture, first symmetry 1, then symmetry 2. If you apply it the other way around, symmetry 2, then symmetry 1, you'll get different results. So combination, the order in which you combine them matters. The order in which you add numbers doesn't matter, but the order in which you combine symmetries does. There are various things like that. You look at the abstract, you get something called group theory, and group theory has proved to be one of the most powerful methods of dealing with problems, not least by the theoretical physicists. So pure mathematicians are used to looking at this sort of situation and deducing from it. Now I can see time is getting on, and I was warned under pain of excommunication not to go on too long. This is what you do with a pure mathematics. What about faith? Well, with faith you start with your beliefs. You look at what those beliefs imply in your life, in what you know about the world, what you know about other people. And then you need to live with the results of that. How does this affect me as a Christian? Well, this is the way in which I would, if I were talking to a mathematician who is a non-believer, and I was trying to explain to him why I do believe, I would say, this is my starting point. God exists and created the universe. So far, I say, just take it as a hypothesis. I'm not asking you to believe it. I'm simply asking you to accept this as a hypothesis. As a pure mathematician, he should be quite ready to look at any hypothesis, possibly to decide that it was rubbish afterwards, but he would look at it. Does this explain all the major, I can see it here. Does this explain all the major themes? This is basically completeness. Does it explain everything? Completeness was, can every formal statement be proved? Completeness for faith means, does your hypothesis, your faith hypothesis, does it explain all the things, all the major things? I'm not saying does it explain why snow fell yesterday and caused such chaos, but does it explain the major things about life? Does it explain why there is good and evil in the world? Does it explain why some people act in what is obviously a very self-denying way? Does it explain other things? Does it explain why the world, the universe is as it is? And I would claim that Christian faith, I know the hypothesis was just a one line, Christian faith is more than just that one line, but that's the basis. Does it lead to any internal contradictions? This is consistency. Now, I've looked at a number of other faiths to some more or less extent, but one which came home very much was, I don't know if any of you have experienced Mormon missionaries. You know, two very smartly dressed, very nice young men would come at the door and would want to talk to you. And we invited them in, and we had several sessions with them, and we discussed. Initially, we just let them present their case, and then we started discussing it. And very rapidly, it was possible to show that they were inconsistent, that there were internal contradictions in what they believed. They stopped coming. They just disappeared. I wonder why. Now, if you accept, yes, that is God, how on earth are you going to know anything about God? Because your hypothesis is that he created the universe. He is outside this universe, so he cannot be reached by telescope, microscope, any form of physical measurement, how are you going to learn about him? And the one answer is going to be that you will only learn something about him if he reveals himself to you, if he allows himself to be known by you to some extent, not fully. We cannot possibly know God fully because he is far greater than anything that we could possibly imagine. I know we've got a huge number of cells in our brain, but it's still a finite number. So how are we going to know anything? So we're going to know it only through his revelation, and his revelation is the Bible. Now, one of the things that struck me relatively recently about the Bible was that it's a book that was written over a long period, was finalized, was finished roughly 2,000 years ago, slightly less, I suppose, than 2,000, but 1,950, whatever. A long time ago, but it was written over a period spanning close on 1,000 years by a number of people. And it is, if it is God's revelation to us, it's got to be something that will be understood by everybody, capable of being understood by everybody throughout all time. Now, I once managed to buy a maths textbook which had been printed in 1642. I managed to make sense of it, but it was jolly hard work. It was very, very difficult because it was written in such a different manner from anything we do now. I've looked at some old maths books, and if they're more than about 100 years old, they become difficult to read. If they're 300 or 400 years old, they require a great effort to read, and certainly you need to have great technical knowledge as well as good eyesight to read them. Isn't it remarkable that the Bible, written at least 2,000 years ago, can be read and understood by someone with practically no education at all, except being taught how to read? That's incredible. It's the only book that's ever been written that can be understood by anybody at any age with very little training. Even the great books of Greek and Roman times, when translated, still are meaningless to a person in the street who hasn't been trained in classics or in literature of some form. I would say, to me, that is one of the most powerful pointers to the fact that the Bible is not an ordinary book, it's the Word of God. So, does the whole story fit together? I assume the existence of God and created the universe. It explains everything I need to know, all the major points. It's complete. It explains everything. It's not inconsistent. It doesn't contradict itself at all. It has things like the Bible, which give me a link with God, which explain to me things that I could never otherwise find out, and which do it in a way which is completely unique. Doesn't that mean that that is something in which I can put my trust? So I'll leave that thought with you. Yeah.
I've got one about, is Euler's theorem, e to the I pi equal to -1? Why for him was that conclusive evidence that God existed? Could you expand on that a bit without getting too mathematical?
He didn't give a written explanation of that, so it's surmise. But I think it was that, I mean, for us, that is not too surprising because we are familiar with all three of those numbers, e, I, and pi. And they've been known for a long time, so certainly if you're a mathematician, you know them, and they're old friends. And as I said, they make trigonometry easy, so there must be something good about them. Pi, of course, was known, although not to that degree of accuracy. Euler, in fact, found a formula for pi which did enable that long calculation, at least if you took the time to be made. And he knew a bit about E. I was pretty recent in his day. So they were things that were to him very new, very strange, and very unconnected. So the fact that they connected meant that, there was something marvelous about this. It's, I suppose, a mathematician's version of the person who sees an absolutely brilliant sunset, or as I was talking to Paul about earlier, the Northern Lights in all their splendor. You won't see them from here, I know, but if you're up in the far north, you would. You see something so beautiful, so incredible, that it makes you realize there's something more to it than just a collection of atoms or whatever. Yeah.
On the same kind of point, surely as a mathematician you can appreciate that that's statistically really insignificant. If there are so many of these numbers, there are so many numbers which don't fit together to do anything, and yet they're latching onto this one which happens to, and making it out to be this massive big coincidence. No, I'm no mathematician, but that's how it seems to me.
Yeah. Well, the fact that these ones which play a very important key role in a lot of mathematics. You see, pi came out of the circle and the size of the radius, the diameter and the circumference of the circle, but it turns up in a lot of other situations too, that precise number. E turns up, it's fundamental to a very wide variety of areas, as Mark mentioned, in biology, in finance, shall I say, but in a lot of other things, in behavior of a lot of systems. So they are key numbers in the working of the physical world. And that has, well, depends upon whether you agree that it's a number or not, because it's square root of -1, but it does, again, it has a very major role to play in a variety of situations. They are three numbers which, if you think of numbers as mountains scattered all over the world, they're sort of Everest, K2, and whatever the third one is. They are very important numbers. But they are numbers that cannot be pinned down in any way other than by their properties. They're not solutions of anything.
You said... Sorry.
No, it's all right.
That's something. You said that the only way you can know God is by Him revealing Himself to you, and that God exists outside the universe.
Yeah.
Is there any evidence for God's existence in the natural world?
If you mean, is there something that you can measure? No, there isn't any direct evidence other than the fact that the universe exists. Because, let me think, in 100 years ago, the structure of the atom was starting to be clarified. The first experiments proved that there ought to be something like the electron. But but it couldn't be captured, it couldn't be measured, couldn't be found anything. Later on, I don't know whether you would recognize it, neutrinos. They can't be seen, they can't be measured. They've eventually, after a very long time, found a way of discovering. But for a very long time, the only way they were known to exist was because of theoretical deductions from known facts. So you can't always measure something. Now I know that in those cases they eventually found them. And of course the Large Hadron Collider is supposed to show the existence of something which has been hypothesized, the Higgs boson, and that should be of interest to us because Peter Higgs is a retired professor of physics from Edinburgh University. But you see, the whole point is if God created the universe, there's not going to be anything inside the universe which proves that he exists, because to prove that he exists, you've got to prove that he created the thing that you're trying to measure. So
you have been born in Morocco in a Muslim family.
I wasn't in a Muslim family.
No, but if you were,
if you had
been,
if
I had, yeah.
Do you think that you would still follow Christianity as a religion, or would faith have revealed itself to you through Muhammad and its preachings? And if that is the case, which I believe most people would admit, what's the big deal between different faiths if it happens that where you are born is the major factor determining what kind of faith you are going to follow?
Okay. Yeah. I mean, I can't say for sure. Oh, I'll just stay in front of this thing. I can't say for sure what I would have done if I had been born into a Muslim family. What I can say is that I think I probably would have ended up doing mathematics, because it seems as if, I mean, it's the thing that I'm good at. It's a thing that I love. I love doing mathematics. So I probably would have ended up doing mathematics. And I almost certainly would have ended up thinking in terms about what I've called completeness and consistency. And on both those counts, Islam does not make the bill. So I don't think I would have been I would probably have started as a Muslim, because you tend to start believing what your parents tell you when you're very young. But as I grew up, I think, and became a mathematician, I would have started thinking about it. But I believe that it's not just a matter of what I do that makes me a Christian. It's a matter of what God does in me.
Which bit of the mathematics that seemed so complete and leading to a God would have told you that Jesus Christ and the Bible is something to follow and not the teachings of Muhammad?
Right. Well, as I mentioned, the Bible itself and what it tells me about God, to me, is both complete and consistent, to use a shorthand. And the Bible does talk about Jesus Christ. Also, all known facts about Jesus Christ fit in with what the Bible tells. There are a lot of facts known about Jesus Christ and about what happened 2,000 odd years, well, no, not 2,000 odd, slightly less than 2,000 years ago. And they all fit in. So that is what would have led me to, would have reinforced my belief in the Bible.
Yeah, I wouldn't mind focusing in on your claim that the Bible's timeless. Well, you didn't use that word. That anyone can understand it regardless of time. Well, I mean, if I read a Bible from earlier than the King James Bible, maybe, I probably won't be able to read it because of its archaic language.
Mm-hmm.
I won't be able to read it, because, so, I don't get what you mean that
Well,
just because it's written differently, what significance does that have? I don't get it.
Okay, well, I probably didn't answer pretty clear. When I say read the Bible, I didn't mean that anybody with even very little training or just being able to read would be able to read the Bible in the original. I mean, I can't read the Bible in the original. It's Hebrew, the Old Testament's Hebrew, the New Testament's in Greek. I know the Greek letters because I'm a mathematician, but I don't know what a Greek word means. Well, one or two, but not many. No, you have to rely on translations. But the translations of the Bible are as faithful as the translators can make them. And there's always some modification as years go by. I don't know if you have... I was brought up, in fact, on the King James version, the authorized version. And to me, that is still the version I know best, because I read it many times when I was very young. And when you read something a lot when you're young, it sticks in your memory. It's much more difficult to make things stick in your memory as you get to my age. You just forget things. But yes, you have to look at translations. What I mean is that if you take a translation in the language of the person who's reading it, then that person will be able to understand it and make sense to them. There are one or two little things which would have to be explained a bit. For instance, a lot of the parables in the New Testament are rural based. They're about animals, they're about shepherds, they're about oxen, they're about life in the farm and so on. And of course, if you're brought up in the slums of Mumbai, I was just thinking of Slumdog Millionaire, I don't know if any of you have seen it, but if you're brought up in the slums of Bombay, you've probably never seen a shepherd and sheep and so on. So you'd have to explain a bit of what that means. But that is more a matter of translation rather than a matter, it's not a thing. If you look at, well, I had to do Virgil in translation. Well, I had to translate some of it when I was doing what were then called O-levels. Not only did I have to have the things explained to me, but the whole story meant nothing to me. Actually, it didn't mean nothing to me. It meant a pass to enable me to get into university, but...
I'm not sure about that. I mean, I studied Virgin myself while I was at school.
Yeah.
And as soon as you translated it, in the same way that you can translate the Bible into the modern vernacular, you can translate Virgil in much the same way. It's the translation that's the problem. So I don't see how the Bible is any different to any other book that was written at the time. We have histories of Caesar, which we can read and we can understand. But I don't see your point.
What about the
I
Iliad
think
and the
you're
Odyssey?
probably more intelligent than somebody who's just able to read, and so you probably do pick up a fair amount of Virgil. But I think if you gave a translation into the modern vernacular of Caesar or Virgil or one of the others to somebody who had little education beyond the age of 8 or 9, who just learnt to read and stopped there, it would mean nothing to them. Other than a story about, well, depending upon who it is, a story about conquest or whatever.
This is just clarifying from my experience of reading the Bible, is that I find it's a self-defining book, in that all of the major terms that it uses, it defines as it goes along. So like in the early books of the Bible, it defines what faith is by Abraham sacrificing Isaac, and then that definition is carried on through the Bible. So every major theme that it has, it kind of defines the words it uses before it uses them. In that way, is it similar to, the definitions you have in mathematics and things like that, that you define your terms very clearly and then you can use them as much as you like?
Yeah, to some extent that's true, but I think faith actually is defined in Hebrews, not in the early part. And then examples of faith, including Abraham and so on, are given. I think the idea of faith, that is that you trust somebody totally with your life or with the life of your child, is an idea that would have existed, that exists in everybody's meaning. I mean, I think it's an idea that it resonates very strongly with anybody who has a child of their own. Because parents, well, good parents, are parents who are ready, if necessary, to sacrifice themselves for their child. So that idea of faith was there a long time.
Go on.
Just a short question.
I've asked the question already.
Why do we not see any evidence of God today? I mean, why don't we see any evidence that God exists today? Because in the past, did you not interact with the physical world, like by talking to Moses through a burning bush or parting the Red Sea? So if you can interact with the physical world and communicate, why doesn't he do that today?
The very short answer to that is, I don't always understand what God does, because he's far greater than I am. And what he does is right. The decisions I take will not necessarily be right. But I think the reason is that God adapts his way of interacting with individuals to the individual and to the time. Now, you're talking about God talking to Moses in the burning bush. That was the way in which Moses interacted with God, and God talked to Moses face to face, the only man to whom that has ever happened, and that is in the Old Testament. I think God does talk to individuals now, but not by a burning bush. He talks to you by the Spirit working in your life.
Today, there's maybe a lack of faith, it would be quite simple for him to actually interact physically with us as a people, or even prove that he exists to us, through miracles of some kind.
Yes, and that is the content of one of Jesus' parables. God, and in effect it's saying God could force you, but then you wouldn't be a free person. The story of Lazarus, who wanted God, when he died, wanted God to raise somebody from the dead to talk to his brother so his brother wouldn't follow him into hell. God said, even if I rose from the dead, he wouldn't. Even if someone rose from the dead, he wouldn't believe. We're free in agents. God does not force us to do anything. He doesn't turn us into robots. And whatever he did now, there would be, if you were determined, if an individual, I don't mean you personally, I mean if an individual did not want to know God, then he would reject whatever he saw or heard or experienced. Mark?
Can I comment on that? Miracles in the Bible were very specific. It's not like, and they were over thousands of years. It's not like the Bible said that miracles were happening, every other day. We're talking a huge span, and each miracle was specific to God's plan of salvation that ultimately led to Christ, including, like the one that was used as an example, the burning bush, because that was God redeeming his chosen people to bring them back into the promised land, which ultimately became Israel and the Jewish people and led to Jesus Christ. So that's just one example. But beyond that, I can testify that God still is doing miracles. Just because it's not in the news doesn't mean that he doesn't do miracles in people's lives. I know that personally.
Do you have any evidence for that?
Sure. My father-in-law.
Scientific evidence?
Well, no, because you can't prove, because a miracle is exactly that. It's a miracle. It's something that is not proven by the natural. It's supernatural. If it was natural, it wouldn't be a miracle at all. So by the very definition of a miracle...
That's a nice way out, isn't it? That's
no,
way out.
it's not a nice way out. It's the truth. You're talking about a miracle, right? By very definition, you're talking about something you're saying is supernatural. If it's natural, then it's not a miracle.
Then you would have evidence of the natural order being upset. Sorry, we're taking over the entire question.
But you can see what I'm saying. I'm not really. Well, that's the answer.
You can hear what you're saying, not see. There's a mathematician for you.
Yeah.
But going back to the mathematical evidence for God or the science of God in mathematics, the speaker nicely put it that you see God outside the universe creating it, and what we've been talking the last 5 minutes is quite different. You have a God in what we've been talking about the last 5 minutes is quite different. We have a God inside the universe, talking to humans, performing miracles, altering the laws of physics for some purpose. That is very different from what your talk has been about, some evidence for an outside the universe God. How do you reconcile the two?
Okay, when I say God is outside the universe, but that doesn't mean he can't interact with the universe. There's actually a very good example of that. There's a book called Flatland, which I don't know if any of you have heard of, in which talks about a world which is two-dimensional. Everything lives in 2 dimensions, and it's a story about it. It's written by a mathematician. And you see, the point there is that a 3-dimensional person is outside this world of 2 dimensions, but he can interact with it. But for instance, if he puts his finger in it, the 2-dimensional world sees it simply as a flat disk, but it's a finger. God can interact with the world he's created. Sorry, what was the last part of your thing? I forgot now.
There's no need to reconcile. I misunderstood. I thought that God was kept outside.
Yeah, I mean, he's not. He is outside the universe because he's created the universe, but that doesn't mean to say he can't interact in and come into the universe as he did in Christ. The other thing is, I think there's a danger. There's a danger in talking about the laws of physics. They are not laws. They are hypotheses based on data. Now, if one of the data says that this law goes against this law, that means the law is wrong, not that the data is. So the laws of physics is actually a bad use of the word law.
So where do you see, if that makes them, sorry, I'm just trying to articulate this. If something breaks the laws of physics, that makes the laws wrong, then what room is there for a supernatural miracle? If it just means the laws are wrong.
Could you define miracle for me, then I'll tell you.
Okay, an event with no natural explanation.
That just simply means that you don't know what the explanation is. That's all.
So there's no miracles then? You don't know what the
miracles in the sense that they break the fabric of the universe. No, they don't exist.
What's the fabric of the universe if not the laws of physics?
The laws of physics are simply theories that account for certain hypotheses.
What does it break then? What does a miracle break?
Well, that is the good question. Exactly what do you mean by saying that a miracle breaks something? It's actually a very... You see, the trouble with the word miracle is that it has dozens of different meanings, depending upon what context you're using it in, and we tend to mix the different meanings up, which confuses matters. But, I mean, I know of a case of somebody whom I knew very slightly, who had cancer, quite bad cancer. They were prayed over, and the cancer disappeared. That is a miracle in the usual sense of the term. I also know people or heard of people who in similar circumstances who were not at all religious, had nothing to do with religion, where cancers have spontaneously disappeared. Is that a miracle? If so, what? You see, these things happen. For me, what makes something a miracle is the fact that I can see God at work in it. But it is a fact. And if you're making studying and trying to create a quote law, I don't like the word law, a theory to cover this, then it has to cover that event. Any theory about people has to cover all the events to which it refers.
I found your metaphor or analogy of the mechanic that can tell you how the parts of a car work as being as much as the mechanic can do, and having faith come to you to answer questions about the designer of the car. That to me seems very relevant, very important. I can talk to the mechanic and see how the car is made. That's as far as I'm going to go. And it's still, I believe, that I can tell the difference between a good car, well designed, and a bad car, bad design. In the same way, I can see, I can get an engineer to tell me about a bomb with lots of nails to make lots of injuries, and I can see the bomb, understand the bomb, and I can also infer something about the creator and the designer of that bomb being an evil person. So when I see a 2 or 3 year old girl dying from cancer in a hospital, I can have a scientist telling me about the nature of the cancer and how it develops, and that's as much as the scientist will tell me. However, I will need my faith to tell me something about the designer that allows things like this to happen, which to me would tell me things that do not fit with major biblical books or faiths of this world.
Yeah, I mean, the problem of evil and suffering is basically what you're talking about. Yes, well, I mean, if you go to the very beginning of the Bible, you learn about man rejecting God and evil coming into the world, what is generally called the fall. And God made man free to choose or not to choose. Man chose. Actually, I'm being sexist, aren't I? And it was woman who chose first. I'm safe because there are not too many ladies here. The human beings chose to turn away from God and brought evil into the world. Now, God allows men to be free. God wants men to turn to him freely, not to be coerced. So evil is in the world. So there is cancer. So there are people who make bombs with nails in them, and so on. God could stop that, yes. But he could stop it at the cost of destroying freedom. What he has done is do the most, while giving human beings freedom, do the most that can be done, and that is to send his son to die for our sins. And that it's not the end for a child who is dying of cancer. That child will go to heaven, to a much better life.
Because you can explain away things like... Sorry, were you not finished?
No, they're two started up together.
Because you can explain away certain things by freedom and free will, but not natural disasters. They must be caused by God.
No, natural disasters are not caused by God. The whole of creation fell.
I wanted to make a point going back to what you said just slightly earlier. I mean, does God actually choose who decides who's going to suffer in this world and who gets an illness, who doesn't? I mean, if you have to believe in God, does that mean you're not going to fall ill?
No.
Because you're not turned away from God, so surely you should be exempt.
You're in an evil world.
But you yourself wouldn't be evil.
We're all sinners.
Some more than others.
So, yeah, I mean, I'm not saying I don't mind suffering. I do mind suffering. What I'm saying is that to me, what is most important is being a child of God, and that I know that eventually I will be with God. And so I'm not worried about, well, I won't say I'm not worried. I will put up with whatever comes my way in an evil world, in a world in which evil reigns. So,
at what point was the world not evil? Was it before or after the Precambrian?
Excuse me, do you believe in
science?
Does evil exist?
No, but I assume you do.
Okay.
But you believe that. So, at what point do you think there was no evil in the world?
Okay.
Was it before or after Precambrian?
No, I'm not sure when Precambrian was anyway, because I get totally mixed up with the geological ages. But yeah, I know what you're getting at is, was it before or after the fall?
What was the fall?
The fall was when men turned away from God.
So it must have been in the last 200,000 years then.
No.
Well, that's the only time when men have been on the earth.
10,000 years.
According to some men.
According to all the scientific evidence.
No, that's
Okay. That's something for which there are a number where Christians would have a number of different answers. If you want, I'll tell you.
Consistency.
What?
Sorry.
Bible
we're
is
discussing about
Christians.
we're discussing about mathematical consistency.
Yeah, consistency.
I believe it refers to consistency right here.
It doesn't. What comes from the Bible is consistent. That doesn't mean to say that each of us sees it in a different way, but it's consistent for each one of us. Sorry, now to get back to you, I've thought quite long about that, because yes, it is a problem. And the answer I have is one which is very unorthodox. So Paul and others, please close your ears at this point. You see, one of the things that I'm always interested in is the fact that time is only measured in this universe. It's the rate of increase of entropy, of disorder in the universe as a whole. And it's defined precisely in various ways. Okay. Outside the reference frame of the universe, time does not exist, because time is simply a measurement made within the universe. Time does not exist for God. And that there are statements in the Bible which imply that. There's a famous one that one day is as 1,000 years and 1,000 years as one day. So time does not exist for God. So in God's in God's frame of reference, time does not exist. When the fall came, my view of it, and as I say, this is highly unorthodox, so my view of it is that at that point, the whole of creation changed, forwards and backwards in time as measured in the universe. Okay? Which means that what was happening in Precambrian times before the fall, we just don't know, because the fall changed everything forwards and backwards in time. It was like dropping a stone in a pond. The ripples go out in all directions, in time as well as space.
That's unorthodox. That's unorthodox.